Okay, we spent so much time talking about making AI smarter, faster, more capable. But today we're going to dive into something that might just be even more important. How to build AI that's actually reliable, that's resilient, and that knows exactly what to do when things inevitably go wrong.
I mean, really think about that for a second. We're plugging AI into our most critical systems, right? It's running global logistics, it's powering massive enterprise software. It is absolutely brilliant when it works. But it brings up that one question every single engineer has to answer. What's your plan for when it fails? Because let's be honest, every complex system sooner or later hits a wall. So let's start right there with that fundamental reality. This is not some hypothetical what-if scenario. When you're dealing with a sophisticated AI workflow, failure isn't just a possibility. It's pretty much a statistical certainty.
Now, here's where it gets really interesting. As we give AI more and more responsibility, the consequences of those failures just get bigger and bigger. A simple chatbot glitching out, that's an annoyance. But an error in an AI that's managing a supply chain or a financial trading system, whoa, that is a serious, serious problem. And that's exactly why just crossing your fingers and hoping for the best is not a strategy. And that, of course, brings us to the solution. If we know that failure is a given, then the only professional way to move forward is to have a super solid plan for it. This is where we get into the real art of having a plan B, and maybe even a plan C or D.
The official name for this strategy is exception handling and recovery. Now, the key thing to get here is that this isn't just about your program crashing and throwing up some generic error message. No, no. This is a proactive design pattern. It's about building a system that can intelligently figure out what kind of error it's dealing with and then automatically switch over to a pre-planned backup. It's smart.
And here is the core idea that makes this whole thing so powerful. It's the recognition that not all errors are created equal. I mean, think about it. You wouldn't treat a temporary traffic jam the same way you treat a bridge that has completely collapsed, right? And your AI shouldn't either. This slide just lays it out perfectly. On one side, you've got your temporary failures. Think of a server that's just busy for a second, or a momentary network hiccup. The problem is probably going to fix itself. So what's the strategy? Just wait a bit and try again. But on the other side, you have permanent failures. A corrupted file, a bug deep in the code. Trying the exact same thing again is completely pointless. It's just going to fail again. So the strategy has to be totally different. You stop and you switch to another plan entirely. So how does this actually work for those temporary glitches? Well, when the system thinks the problem will just go away on its own, it takes this patient, wait-and-see approach. But as you're about to see, it's a very smart kind of patience. This whole process is often called exponential backoff, and it's actually pretty clever. So first, the agent tries to do its thing. Let's say it fails. Instead of immediately trying again and hammering the system, it waits for just a little bit, maybe 1 second. Then it retries. If it fails again, well, now it waits longer, 2 seconds, then 4, then 8. See the pattern? This increasing wait time prevents it from overwhelming a system that might already be struggling. But, and this is so important, there's a cap. If it still can't get through after, say, 5 tries, the system just gives up. So the takeaway is simple. Yeah, retry, but do it intelligently, and always have an exit strategy. Okay, but what if the problem isn't temporary? What if that file is just toast, or an API it needs is gone for good? Trying again is useless. This is the moment where the system needs to pivot, hard, to a totally different path. It's officially time for Plan B. And there are a few standard moves here. The AI could, for instance, switch to a simpler, maybe less powerful, but super reliable model just to get the job done. Or it could use the last good piece of data it managed to save, like a cached result. Sure, it might be a little out of date, but it's way better than nothing. And then, of course, there's the ultimate fallback. It can call for help. It can send an alert to a human operator saying, hey, I'm stuck, I need you to take a look. The key for these permanent failures is to stop retrying and start adapting. So we've seen how it all works, but why go through all this trouble? Let's talk about the payoff, because it is about so much more than just preventing a crash screen. It's really about building trust and gaining incredible insight. And let me be clear, this is not just some theoretical concept from a textbook. Exception handling and recovery is the absolute cornerstone of any serious, real-world AI application.
You will find it everywhere, in production QA, in massive enterprise deployments, and in basically any system that is considered mission critical. It's what makes an AI system tough enough for prime time. And there are two massive benefits here. First, a huge increase in user trust. I mean, when people know that a system has fail-safes and won't just fall apart at the first sign of trouble, they're way more likely to actually rely on it. And second, and this is so important, is performance visibility. Every single time a fallback plan gets triggered, it gets logged. And that data, it's pure gold for developers. It gives them a crystal clear map of where the system is fragile and what they need to fix next. But of course, this pattern isn't some magic silver bullet. Building this kind of resilience is a serious undertaking. And yeah, it comes with its own trade-offs and some hidden complexities. So what are the cons? Well, for one, this adds a ton of complexity to your infrastructure. You're not just building one workflow anymore. You're building multiple backup workflows and all the logic to switch between them. That's a real engineering cost. Second, there's the human factor. If your system is constantly crying wolf and sending alerts for tiny, non-critical issues, your human operators can get alert fatigue. They just start tuning out the warnings, which means they might miss the one that's actually critical. And this quote right here really captures the entire philosophy behind this. The goal isn't to build a perfect AI that never, ever makes a mistake, because that's impossible. The goal is to build a resilient AI that, when it does fail, fails gracefully, predictably, and safely. Which kind of leaves us with one last big thought to chew on. As we keep pushing the boundaries of what AI can do, we're all naturally focused on making it more intelligent. But maybe, just maybe, the even greater challenge, the one that will truly define its success in the real world, is making it better at failing. What do you think? Thanks for joining me for this explainer.